how does your operating system actually implement a recursive code. To do that, it uses a stack data structure, and that stack data structure is basically a stack of function calls. Okay, so whenever a function call is made, that new function call which is made is pushed on the top of the stack, and whenever whatever function is there at the top, if that function returns or it exits, then that is popped out from there. So that is how it happens. So now I'll very quickly do it. So keep looking and keep your focus very sharp, because we are going to be a bit quick over here. So that function was like this, void func, and this took an integer x. Okay, and now the first thing that it did was to print the value x, and then it had an if condition. If x was greater than equals to 3, then in this case I was simply going to exit or return. Okay, next it was going to invoke func of x plus 1, and also after this has been completely finished, then it will call this. Okay, so I broke them into some pieces of instructions. I said that, hey, I'll call this instruction 1, I'll call this instruction 2, I'll call this instruction 3, I'll call this instruction 4, and let's say the main function calls for the initial value of x as 0. Yeah, so the first thing that is supposed to happen is that initially there is an empty stack, and since you invoked f of 0, so f of 0 will come over here, and till now no instructions have been executed, just a call has been made, right? No instructions are executed. So I'll say that, hey, 0 instructions are executed. These are instruction numbers, okay? 1, 2, 3 and 4. Now let's see what happens. So whenever call to f of 0 is made, the first thing it will do is it will print the value of x, which is 0. So it will print 0. Okay, now it will come to this if condition. This if condition will be false. So now what will happen? Now it will invoke f of 1. So if you take a look, f of 0, when the call to f of 0 was made, instruction 1, instruction 2, instruction 3 happened, right? Till instruction 3 it happened, and after that the call to f of 1 got made, so f of 1 will get pushed into the stack. So I can say that the 3 instructions of f of 0 have been executed till now. Okay, and since f of 1 has just been called, so 0 instructions for it. Okay, now after this what will happen? Now f of 1 will start executing. So for f of 1, what is the first thing it will do? It will print the value which is 1, right? Now it will come to this if condition. For 1, this condition is false, so now it will come over here, and what it will do? It will invoke f of 2. Okay, so now the top of my stack will contain f of 2, right? F of 0 had been untouched in the last step, so it's 3 instructions. For f of 1, how many instructions are executed? By the time f of 2 comes to the top, for f of 1, how many instructions are executed? 3 instructions, right? It printed, it evaluated the if block, and it made a call to f of x plus 1, which is f of 2, right? So 3 instructions for this. For f of 2, just entered, so 0 instructions. Now f of 2 is at the top, so what will happen? First thing that will be done is to print the value of x, which is 2. If condition will be false for x equals to 2, and then it will invoke f of x plus 1, which is f of 3. So now at the top of the stack, I am going to get f of 3, right? So 3 instructions for this, 3 instructions for this. How many instructions for f of 2? How many instructions for f of 2 are executed? Again 3, right? 3 instructions for f of 2. And for f of 3, 0 instructions. Yeah. Now what should happen? So now f of 3 will get executed. So the first thing it will do is it will print the value 3. After this it will come to if block. What will happen if it comes to the if block? Will the condition be true or false? The condition will be true. So since the condition is true, what will happen? It will exit. What is the meaning of exit? Exit means that this function is now done with its job, and it should now not reside in the memory. So what will happen? That this will get popped out. Okay, so basically this f of 3 will get popped out. Now the moment this f of 3 gets popped out, control will transfer back to the parent of f of 3, which was f of 2, right? That is the reason we use stacks, because the parent is always accessible, okay, very easily. Now I am at f of 2. So f of 2 had executed till 3 instructions. So what should be the next instruction of f of 3 that should be executed? That should be executed for f of 3. It should be instruction number 4. And what is the instruction number 4? That is to push f of what? F of x plus 2. What will be x plus 2? For x equals to 2, it will be 4. So it will push now f of 4 onto the top of the stack. Now how many instructions for the f of 2 are executed? 4 instructions. And for this, 0 instructions. So do you realize the importance of this fact, that why I have to remember how many instructions are executed? Do you realize the importance of this thing? Yeah. Why? Can you tell me why? What is the importance of this? Because when some instruction got popped out, and let's say the control transfers back to the parent, then I should have a way to know that, hey, for this I had already executed 3 instructions, so I should start from here rather than starting from the first place again. That is the reason I need to track that how many instructions for a particular function has been executed. Is that perfectly clear to everyone? Let's say yes. That's clear to all, right? That's the reason your system keeps track of this thing. Which is more beneficial, recursion tree or stack? It's not about what is more beneficial or less beneficial. It is just about that your system actually implements things using stack. But if you have to predict output of a code or something, then instead of drawing this, you simply draw your recursion tree diagram, because that also gives the same kind of picture. Okay. Now you are at f of 4. Okay. So what will first happen? It will print the value of 4, right? After that, it will come to this condition. So what will happen? 4 is greater than or equal to 3, so this will be true, and now it will return. Returning means what? That f of 4 will be popped out. So f of 4 has been popped out. Now it looks like f of 0, f of 1, f of 2. 3 instructions, 4 instructions. Now the top of the stack is 2. So now what should happen? The top of the stack is f of 2. And for f of 2, how many instructions are executed? Tell me. Can I say for f of 2 all the instructions have been executed? So if all the instructions have been executed, then what should happen? Then it should be popped out, right? So see, for a particular function called to get popped out, either of the conditions should be true. First condition, either it should return explicitly, or that particular function has executed all the instructions. Okay, if either of these two are true, then the pop will happen, right? So after this, what will happen? It will simply be popped, and now I have f of 0 and f of 1. Is it perfectly clear to everyone what I said? When should the pop happen, right? So this is how, the logic that you have in your operating system that implements this recursion, that logic to pop considers these things, that either the entire body of the function should be over, which is all the instructions are completed, or the second thing is that the function explicitly returned something. Okay, cool. I think after this, again, you can go on. What should be the next step? F of 1. How many instructions got executed for f of 1? 3 instructions were already executed. So I should directly come to the 4th instruction, which is invocation of f of x plus 2. For f of 1, f of x plus 2 will be f of 3. So it will push now f of 3 to the top of the stack. Okay, 3 instructions for this. And now for f of 1, how many instructions are executed? After f of 1 pushed f of 4, how many instructions? 4 instructions. All the instructions got executed. Okay, so now the top of my stack is f of 3, and this has been newly pushed, so 0 instructions. Yeah. Now what I should do at f of 3? First thing, I should print the value 3. Then I should come over here. Is this condition true or false? For x equals to 3, this condition is true, right? Since this condition is true, so what should be done? What should be done? Whatever is the top of the stack, that should be popped out, right? So now I'll have f of 0 and f of 1 with me. For f of 0, 3 instructions. For f of 1, 4 instructions. What should happen next? Now whatever is the top of the stack, for that all the instructions are already executed. So should pop happen again? Yes, the pop will again happen, right? So as a consequence of that, what is going to happen? I am going to get back to f of 0, whose 3 instructions have been executed. Now for f of 0, 3 instructions are already executed, so I should come to 4th instruction, which says to push f of x plus 2. So now what it will do, it will put f of 2 to the top. And now for f of 0, how many instructions are executed? All the 4, right? And f of 2 has just been pushed. Okay, so now I think you can realize, so see, when f of 2 was at the top, whatever happened till the time f of 2 got out, the same sequence of thing will happen from here onwards also, isn't it? Yes, no, right? The same sequence of things will happen. Let's do that quickly anyways. So at f of 2, the first thing that you will do is you will print the value 2, okay? And then you will come to this if condition which is false. So now you will invoke f of 3, okay? So now your stack looks like this: f of 0, f of 2, and f of 3 is at the top. For f of 0, 4 instructions. For f of 2, how many instructions are executed now? By the time f of 3 is pushed, 3 instructions, right? So mention that. And for f of 3, 0 instructions, right? Next, what should happen? At f of 3, first you will print the value which is 3. And now the if condition will be true, so you will pop this, okay? So now you get back to f of 2, whose 3 instructions were executed and 4. Now f of 2 had already executed 3 instructions, so now it will invoke the 4th instruction, which is to push f of 2 plus 2, which is 4. So now it will bring f of 4 to the top of the stack, and now for this one also all instructions are executed. What will happen for f of 4? It will first print the value which is 4, and the if condition will be true for x equals to 4, so it will be popped. Now you just have f of 2, f of 0, all instructions are executed. What will happen? All instructions are executed, so it will simply be popped. Now f of 0, all instructions executed, simply popped. Started with an empty stack and ended with an empty stack. So what will be the space complexity? Can I say the space complexity would be the maximum size of stack at any point of time during this entire process, isn't it? Yeah. So it needs not necessarily be order n, okay? It should simply be the maximum size of stack that you ever encountered. And when did you encounter the maximum size of stack? You encountered it here, and there were 4 function pointers, okay? So order 4 around. And you could have seen this thing even in the recursion tree diagram, isn't it? Because even in the recursion tree diagram, you had a root and you had multiple leaves. So whatever was your maximum length path from root to leaf, that would be the overall space complexity. Is that clear to everyone, guys? Are you getting this thing, right? So even if you draw the recursion tree diagram again, you will see that the maximum path length that you would ever have, that would correspond to this case and this case. And that is the, recursion stack size and nothing else. Okay, cool. So after having understood this thing, you should not be facing a lot of problems while dealing with the basically trying to understand an already written recursive code. You will be very easily able to understand that. I would say that take this as an understanding, but for you to actually understand how a recursive code is working, use that recursion tree diagram, because that also makes the same sense within very fast time. Okay.